Hi, I am Somik Dhar and I will be solving question number 7 of homework 9. Okay, so what do we have given? So we need to prove that a random telegraph signal is a strict sense stationary process. Okay, so now we come to the proof. The random telegraph signal RTS is a discrete time stochastic process that switches randomly between two values, typically denoted as +1 minus and -1. The switching occurs at random times and the duration of each value is also random. Okay, so it you can think of it as like a switching in a digital circuit, like going or a PWM signal circuit. Okay, so to show that a random telegraph signal is a strict sense stationary, we need to show that its mean and autocovariance are time invariant. Okay, so mean of RTS is defined as expectation xt is equals to probability of +1 into +1 plus probability of -1 into -1, where probability of +1, probability of -1, p of +1 and p of -1 are the probabilities of the signal being in the +1 and -1 states respectively. Since the probabilities does not depend on time, the mean of the RTS is constant and does not change with time. Okay, now we come at autocovariance. The autocovariance can be defined as expectation of the signal x t1 minus mu t1 x t2 minus mu t2, where mu t is the mean of RTS at time t. Okay, so we can assume without the loss of generality that t1 is less than t2. That's a fair assumption. Since RTS switches randomly between two values, autocovariance can take only three possible values. +1 when both T1 and T2 are, when the state at both times T1 and T2 are same. -1 when state at times T1 and T2 are different, and 0 when T1 and T2, when the signal switches between T1 and T2. Okay, so let tau be T2 minus T1. The autocovariance function in terms of tau can be written as y gamma tau is equals to expectation of xt minus mu times expectation of t plus tau minus mu. So this gives, if we cross multiply and divide, this gives expectation of t star expectation of t plus tau. Okay, minus mu square. What are the other terms go to 0. So if tau is even, gamma tau is equals to 1 minus mu square. If tau is odd, gamma tau is equal to 1 minus mu square. How 1 minus mu square? So if gamma is even, means both are in the same state. Gamma is or tau is odd, both are in different states. So let's say in both cases the autocovariance depends only on tau and not on the absolute values of T1 and T2. Okay, so we can say that the random telegraph signal, that is the RTS, is a strict sense stationary.